Hi everyone, welcome to this lecture. So in this lecture, we are going to solve numerical example on entropy. Entropy is an important criteria in order to find the information gain, and information gain is used to construct the decision tree. So this is the dataset which we are going to use in our numerical example. So this dataset has 6 columns. The first column is patient ID and the last column is our labels. Our label has 2 values, yes or no. It means if the person or if the patient is a diabetic patient, then it will be assigned a category yes, otherwise it will be assigned a category no. Now we have 4 features: emotional state, liver condition, heart size, and blood pressure. Now, in emotional state, we have 3 categories: sad, calm, and stress. Similarly, in liver condition, we have fatty liver, normal liver, and sick liver. That is, we have 3 categories. In heart size, we have 2 categories, that is large or a regular. And in blood pressure, we have 2 categories, that is low and high. So these are the 4 features. The first column is not a feature, it is just a patient ID, and the last column is our label of our dataset, and these middle 4 columns are the features of the dataset. So basically what we are going to do, basically we have to find which is the most important feature of this dataset. In order to find the feature importance, we will calculate the entropy of all these features, that is emotional state, liver condition, heart size, and blood pressure. When we calculate the entropy of each feature, then we will calculate the information gain of the each feature. So that feature which has the high information gain will be the most important feature, and we will start constructing our tree from that feature. That is, that feature will be act as a root node of the tree. So in this way, we will start by calculating the entropy of each feature, then we will calculate the information gain of each feature, and then we will see which feature has high information gain, and that feature will be called as a root node of our decision tree. So let's start calculating the entropy of each feature. So the first step is to calculate the entropy of the first feature, which is emotional state. So keep in mind, in emotional state, we have 3 categories: sad, calm, and stress. And this is our equation of entropy, which we have already seen in our previous lecture. So emotional state is our first feature, and we are going to calculate the entropy and later on the information gain of this feature. So this emotional state has values sad, calm, and stress. So we have to find the entropy of each of the feature. So sad, calm, and stress, these are the 3 values. So when we calculate the entropy of each category inside the emotional state, so that entropy will be used to find the information gain. So if you remember in the previous lecture, the formula for information gain is that it is the difference of 2 entropies. That is the entropy of the parent and then the entropy of the children. So these 3 are the child of this feature, emotional state. So we will calculate the entropy of each of the category. Then we will calculate the weighted average, and then we subtract it from the parent entropy. So the parent is the whole data set. So let's start calculating the entropy of the first feature, which has emotional state. First, calculate the entropy of a sad, which is one of the category of the emotional state. Now, how we calculate the entropy of a sad? We will use this equation. So basically, there are 2 probability terms. Basically, this is a single probability term, and it is appeared 2 times in this equation. That is, first we calculate the probability, and then we take the log of the probability, and then we will add all the possible values. Okay, let's see how we can apply this equation to calculate the entropy of a categorical value, which is sad, which is inside the emotional state. Now, if we count, sad appears 5 times in this emotional state. There are total 14 values. Okay, 1, 2, 3, 4, and 5. So sad appear 5 times. So this 5 shows the total number of appearance of sad. Now, how many times it appears with the category yes, and how many times it appears with the category no? If we see with no, sad appear 1, 2, then 3. 3 times with no and 2 times with yes. So it means out of its 5 appearances in the column of emotional state, it appears 2 times with the yes label and 3 times with the no label. So this is its entropy with the yes label. That is, it appears 2 times with as a yes label out of total its 5 appearance, and 3 times with no label out of its appearance 5 times. Okay, now this is the entropy with the yes label, and this is the entropy with no label. If we add, because we can see that here we have to add this, if we add them, we will get 0.971. So this is the entropy of a sad in the emotional state. Similarly, calm. Now calculate how many times calms appear. So it is 1, 2, 3, and 4. So calm appears 4 times. Now, how many times it appears with the yes label and how many times it appears with the no label? So here, first appearance is with the label yes. The second appearance of calm is with the label yes. And the last 2 appearance of the calm is with label yes. So it's all 4 appearances are with yes, and there is no appearance with no. So in that case, it is 4 by 4, that is all of its 4 appearances with a label yes, and there is no appearance with the label no. So if we solve this, we will get the entropy value 0. So if you remember from the concept of entropy, which we learned in the previous lecture, that the minimum value of entropy is 0 and the maximum value of entropy is 1. And we know that when all the sample belongs to a single class, in that case, entropy is 0. So here the entropy of calm is 0 because all the 4 samples of the calm present in the feature emotional state belongs to class yes. Now calculate the stress. How many times the word stress appear in the emotional state? So it is 1, 2, 3, 4, and 5. And how many times it appears with yes? So stress 1, 2, and 3. So 3 times it appears with yes, and 2 times it appears with no. So 3 times it appears with yes out of 5, and 2 times it appears with no. So in this way, we calculate the entropy of a stress, and this is our value. So in this way, we have calculated the entropy of the emotional state of the feature of the dataset, and with all its value, that is sad, calm, and stress. So this is the method which we are going to use with all the features. That is, our next target will be to calculate liver condition, heart size, and blood pressure. That is the entropy of all its category values. And then we will decide which feature is providing the more information. Okay, so this is the first step of calculating the entropy of our first feature, which is the emotional state. Now we have to find the weighted average of all these, because these becomes the entropies of the child, and then we have to subtract it from the entropy of the parent in order to find the information gain. So this is our next step. So next step is we have to find the weighted entropy of all values inside the emotional state. So weighted entropy is the sum of all the entropies in the column of emotional state, that is all the values which are sad, calm, and stress. So this value provide us the weight, and these are the entropy values which we have already calculated. Okay, so what is the weight associated with sad? What is the weight associated with calm? And what is the weight associated with stress? Okay. Out of 14 appearances, we have total 14 samples in our data set. So out of 14 appearances or out of 14 samples, there are 5 times sad appears in the column of the emotional state. Similarly, calm appears 4 times out of the 14 presence of the values in the emotional state, and stress appears also 5 times. So if we go back, we can confirm that sad appears 5 times, calm 4 times, and stress 5 times. So if we add this 5, 4, and 5, we will get all these 14 values. So in all these 14 values, so the total appearance or total sample in emotional states are 14. Sad appears 5 times, calm appears 4 times, and stress appears 5 times. So the total samples are 14. So sad appears 5 times, calm 4 times, and stress 5 times. Therefore, the weight of the sad is 5 by 14, the calm is 4 by 14, and the weight of the stress is 5 by 14. Now, these are the values which we have already calculated. So it will become 5 by 14 into the entropy of sad, which is 0.971 we have calculated. So this is the entropy of SAT 0.971. This is the entropy value of calm, and this is the entropy value of stress. So the entropy value of calm is 0, and the entropy value of stress is 0.971. So we have multiplied these entropy value with their associated weights, and if we solve all these value, we will get 0.6936. So this is the weighted entropy. Now, in order to find the gain or the information gain of the emotional state, we have to subtract the weighted entropy of all the entries or the categories of emotional state from the entropy of the whole data set. So now we have to find the entropy of the whole data set, that is entropy of S. So here is the entropy of whole data set. So how to find the entropy of whole data set? Now this is interesting. So we have 14 samples in our data set. Out of these 14 samples, 9 belongs to label yes and 5 belongs to label no. So entropy of the whole data set will be according to the labels. So the yes label appearance is 9 times and no label appearance 5 times. So out of the total samples, 9 labels belongs to class yes and 5 belongs to class no. So based on this information, we will calculate the entropy of S, that is the entropy of a data set, which is now 0.94. Now subtract the entropy of the weighted entropy from the weighted entropy of the parent node, or the weighted entropy of the whole data set. So this entropy of the whole data set will be called as the entropy of a parent, and this is the weighted entropy of the children, which we calculated in our previous slide, that is here. Now subtract these two values, subtract the weighted entropy from the entropy of the parent, that is the entropy of the whole data set. In that case, this is the information gain of the emotional state, which is 0.2464. So in this way, we calculated the entropy of the column emotional state, then the entropy of the data set, and then we subtract both to calculate the information gain of the emotional state. Now this value will be same throughout all the 4 features. That is for the liver condition, for the heart size, and for the blood pressure. But every time this value will be changing because that represent the weighted entropy of a single feature, and that represent the entropy of the whole data set. So this value remains same throughout this calculation. Now next is the time to calculate the information gain of liver condition. For information gain, first we have to calculate the entropy of the liver condition. Now for liver conditions, we have 3 values: a fatty liver, a normal liver, or a shrink liver. So in that case, we will start with fatty, then the second calculation will be normal, and third is shrink. All the concept is same which we use to calculate for the emotional state. Now, how many times the word fatty appear in the column of liver condition? So it appears 4 times: 1, 2, 3, and 4. How many times it appear with column yes and no? So if we see, it appear yes with 1 and 2 times, and also it appears with labels no 2 times. So it is equally present both for class no and both for class yes. Therefore, its entropy is 1. If you go to the previous lecture and see when entropy will be 1, so we have discussed when all the labels are equally divided in the classes, in that time the entropy will be high and the maximum value of entropy is 1. Similarly, we can calculate the entropy of a normal liver value. So it appears 6 times, out of which 4 times it appears with class yes and 2 times it appears with class no. So we can count how many times the normal appear: 1, 2, 3, 4, 5, 6. How many times it appears with the label yes? 1, 2, 3, and 4. So it appears 4 times with the label yes and 2 times with the label no. So if we solve this, we will get the entropy of a normal value, which is 0.9183. Similarly, we can calculate the entropy of a value shrink. So shrink appears 4 times in the liver condition column, 3 with the label yes and 1 with the label no. So if we solve, we will get this value. Now it's time to find the weighted entropy of the liver condition. So if we want to calculate the gain of the liver condition directly, we have to subtract it weighted value with the entropy S. So this is the entropy S, which is the entropy of the data set, and this is our weighted value. So out of 14 appearances, out of 14 samples, the fatty words appear 4 times in the column of liver condition, normal appear 6 times, and shrink appear 4 times. So these 3 values, if I solve, I will be able to get the weighted average. These entropy values we have already calculated. So this is the entropy of the dataset, that the whole dataset, this is 0.94. This is the weighted value of the value fatty. This is its entropy. This is the weight of the word normal appearing in the column of the liver condition. This is the entropy value. Similarly, this is for shrink. If we solve all of this, we will get the information gain of liver condition as 0.0289. So this is done with the liver condition. Now it's time to go for our third feature, which is a heart size. So we will do the same thing or same concept with the heart size. It has only 2 values, large and regular. Now large appears 7 times and regular also appears 7 times. So in large, there are 3 appearances of word large with the class yes and 4 appearances with the class no. So this is our entropy of value large. Similarly, if we see our heart size, one of its value is regular. Regular also appears 7 times in this column, 6 times with the class yes and 1 time with the class no, and this is the entropy value of regular. So the next step is to calculate the information gain of the heart size. So for information gain, I will have to subtract the weighted value of this column from the entropy of the dataset. So the weight associated with the large is 7/14, and the weight associated with the regular is also 7/14. This is the entropy value of the large, which we calculated in the previous slide. This is 0.9852 and this is 0.5916. So these are the 2 weighted value of the entropy, and this is the entropy of the dataset. So if we subtract this weighted value from the entropy of a dataset, we will get the information gain of the feature heart size. So our last column is a blood pressure. So in blood pressure, we has 2 values, high and low. So the entropy of high is 1. Why the entropy of high is 1? Let's calculate how many times high appears. 1, 2, 3, 4, 5, 6. So high appears 6 times. So how many times it appears with no? 1, 2, and 3. So high appears 6 times in the column of blood pressure, 3 with the label yes, and 3 with the label no. So high is equally divided among these 2 labels, that is yes and no. Therefore, its entropy is 1. Now for low, low appears 8 times, out of which it has a label yes 6 times and a label no 2 times. So therefore, its entropy is 0.8113. Now, entropy has been calculated. It's time to get the information gain of the blood pressure. So this is the information gain. We will have to find the weighted entropy, and then we have to subtract it from the entropy of a dataset, which we have already calculated as 0.94. Now, how to find the weighted value of this entropy? Now, entropy for the blood pressure has 2 values, high and low. So the weight associated with high is 6/14. Because a word high appears 6 times in the column of blood pressure. Low appears 8 times in the column of a blood pressure. So these 2 terms will give me the weighted average value of the entropy. This is the entropy of the dataset or the entropy of the parent. So subtract the entropy of the children from the entropy of the parent, we will get 0.0478. Now we have calculated the information gain of all the 4 features of our dataset. These are the values of the information gain. The emotional state has a value 0.2464. The gain of the liver condition of that feature is 0.0289. Similarly, for heart size, 0.1516. And similarly, for blood pressure, the value of information gain is 0.0478. Now, since the emotional state has high gain, therefore it is a root node or a decision node, and split start from this node. So this is the most important feature of our data set, that is the emotional state. So our tree will start from this feature, that is this feature will be our root node. So this is our first split. We have already calculated that the emotional state is the most important feature, and it has three categories: sad, calm, and yes. Now sad has 5 values or 5 samples. 2 of them belongs to yes and 3 of them belongs to no. These are the patients which has associated with yes, having emotional state sad, and uh, and yes and no. That is, these are the total 5 values: P1, P2, P8, P9, and P11. So these are the 5 patients associated with sad. These are the 4 patients associated with calm. They have the emotional state calm. And these are the 5 patients which has the emotional state stress. Now, if we see that in the sad, we have 2 classes, yes and no. But at the calm, the classification has been finalized. So we do not need to split that branch further. Also in stress, we have to divide it further like a sad, because there are 2 classes, 3 belongs to yes and 2 belongs to no. So this is our first split of a tree. We have to continue our tree, and now we will continue our tree with a sad value, because this branch need to split further and this branch also needs to split further. So I stop this lecture here and I will continue this lecture in the next lecture. See you there.